Alright, first, something up here that's very useful. Radicals are just factors, right? So literally the square root of 8 times the square root of 2 is the square root of 16, which we know is 4. You're allowed to multiply them as long, or you can consider them like the square root of 8 times 2. You can put them under the same factor. Same thing as over here, you can divide them. So the square root of 8 divided by the square root of 2 is the square root of 4, which we know is 2, which kind of an easy way of simplifying at times. They can be canceled out as well. I could cancel these guys out and say the square root of 4. Right? Same concept as dividing. The product property of roots and quotient property of roots means the same thing as the power property. Means that both of these would get that root. It's literally the same thing written different. In this situation, a to the n over b to the n. We're just writing it as a root instead of a power. Right? And well, it's a little bit weird to do it this way, but I could write this like this. I could write this as the cube root of 8 times 2, and then I know the cube root of 8, right? And I could say that's 2 cube root 2. And I can do the same thing here. I could say the cube root of 25, or square root of 25 over the square root of 16, which is 5/4. So we get some leeway maneuvering things around. Let's do that here. Alright. So we're going to come down here and do these 4 problems. And after these 4 problems, we get some word problems, but it's not too bad. Alright. So I'm going to start off with this. Everything in here gets a cubed root. So I'm going to say the cube root of 256, the cube root of x cubed, and the cube root of y to the 7th. Alright, so there is no cube root of 256, but we can try to break stuff down, so let's do it. I break that down to 2 and 100 and what is that, 48, which is 2, and we get 72, which is 2 and 36, which is 2 and 18, which is 2 and 9, and I'm stuck. Alright, there's 2 3's here, so the only thing that can come out of that is one set of 2. So that's going to turn into 2, and then over here I'm going to have a radical of 148. Alright, remember that's a cube root radical. And I come over here, and well, there's 3 x's, so they can come out as a single x. There's definitely 3 y's here. So I'm going to show it to you here. This could be written as y, 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 boom, y, 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 boom, and another y. So basically what you can do is you can say, how many times does 3 go into 7? Well, we can see 3 goes into 7 twice, so that's y squared on the outside, with a remainder of 1, y to the first on the inside. And we're done. Finished right there. This guy right here is a little bit easier. It's the 4th root of 81 and the 4th root of x. We're going to write that as 3 over 4th root of x. I'm stopping there. I'm going to come down here. 3rd root of 216. We'll do that. 3rd root of 216. And the 3rd root of x to the 12th. And the 3rd root of y 15th. Well, 3rd root of 216, it breaks down into 6 times 6 times 6. So the answer is 6. You basically just say, hey, how many times is 3 going to 12? You could have x to the 4th with no remainder. How many times is 3 going to 15? You'd have y to the 5th with no remainder, and you're done. This guy right here. So that's really not how I do it. When I do it, I just think about each root. I know the 4th root of 16 is 2. And listen to, watch how I do this. 4 goes into x to 14, right? 4 goes into 14 3 times with 2 left over. And I put my 4th root right there. We could also rewrite this part, x to the 4th root in 2nd power, as 2x cubed, x to the 1/2 power. We could rewrite that as right? We could rewrite that as 2 and then keep my bases and add these, right? I could rewrite those as x to the 3/2 power. Oh, 3 and 1/2. I'm supposed to add those and drop my pencil. Oh. So let me rewrite that again. 3 plus 1/2 is 3 and 1/2. So there's a lot of ways to play with this. We're going to have to practice a little bit in class, but there's one way right there. And we're done with this, page 3.